Additive Appearance was launched as the latest spin-off of the CUIP in October 2023. But the story of this company that will revolutionize appearance creation in the 3D printing world industry is quite a bit older. Today's guest on CUIP On Air is Dr. Alexander Wilkie, who is a specialist for predictive rendering and color science research at the Faculty of Mathematics and Physics at Charles University and a valued member of the Additive Appearance team. Good morning. I welcome you here again with the CUIP On Air podcast. Today we are going to talk in English because we have our guest here, Dr. Alexander Wilkie from Additive Appearance. Welcome and thank you for coming.
Thank you for the invitation.
When we were preparing for the podcast, you've mentioned twice that during your work you have discovered something innovative based on someone else's accidental error. And by one of those happy accidents, let's say, it led you to the idea of additive appearance. So maybe if you can tell us more about the story, how it really began.
Yes, it started quite unobtrusively insofar as we visited some other laboratory that was dealing with color 3D print. Mm-hmm. And at that time, our research group was into highly realistic computer graphics, and that was it. Light transport, object appearance, but only in the virtual space. And we saw these printouts there, and they were pioneering doing color 3D print. Mm-hmm. And the printouts were pretty blurry, and the features on the surface of the prints, the colors were good, but the features were a bit blurry. Mm-hmm. And we thought, we could do better than that. And that's those like in the cartoons where you have little sprockets moving in people's brains. And over the next year or two,
in your head.
Yes, over the next year or two, we actually came up with solutions to make things less blurry in 3D printouts, which is a real problem. I mean, the printouts you get from 3D color printers are by default, for technical reasons, a bit blurry, and we can counteract that. So it's not like we were solving an imaginary problem. The irony, though, was that years later, when we spoke to the people at that other lab, when we told them, and we only started this because we saw your blurry prints, and they said, oh God, no, these prints were actually done with the machine in a misconfigured state. They're not normally that blurry. Mm-hmm. So we actually said that if we'd seen proper prints, we might not even have started the whole research direction. Mm-hmm. But because we saw the buggy printouts, we actually started researching this.
To properly introduce your technology as such and additive appearance, so to make it crystal clear what the additive appearance does, it has developed software that is capable of printing objects in a level of really detail and a color accuracy and a texture that no other company obviously has ever done before. What kind of obstacles you faced and what it's all about, just to mention and really explain what additive appearance does and how.
So, what exists are printers that can print full color 3D objects, and they're basically like an inkjet printer, just a very slow one that builds the object layer by layer from colored inks that harden immediately because you shine ultraviolet light on them after you put the droplets there. And of course, as with any printer, the question is, okay, you have a model on the computer, and you send it to the printer. How do you turn the picture you have there, the object, how do you turn that into actual printer commands? And for 2D print, everybody knows, you can print a colored document on your office printer. There's long-standing solutions for this. How to turn the virtual model on the computer to an actual printer, to the printer commands. And as one can see from the standard, slightly blurry printout, these standard 2D methods, they do work for 3D, but they just don't give you the truly optimal result.
For the surface?
For the surface and for the whole appearance of the thing. And to take this to the full potential of these printing machines, you actually need to take a fairly different approach they absolutely don't use in 2D printing, that doesn't exist in the printer driver space.
Okay.
You need to be able to predict what the thing would look like if it were printed. Because what they normally do is they build a huge dictionary of the values you should be sending to the printer to achieve a certain appearance. And that works fantastically for 2D. That is the state of the art in 2D printing. Except it only goes so far in 3D because of various technical aspects of how these resins are deposited. We, the computer graphics people, we were doing movie graphics until then.
Okay.
Because you want a dinosaur in a movie, you need sophisticated software to simulate that and compute the picture with the dinosaur. We collaborated with movie studios about things like that. And as it turns out, this ability to predict what a dinosaur looks like is, funnily enough, exactly what you need to predict what a 3D printout is going to look like, because that's the core of our software. We can predict what it would look like if we printed it just so, and then we can have an optimizer change that and see, wouldn't it look a little bit better if we rearranged the print a little bit? And if computers are good at doing one thing, it's doing one stupid thing over and over again a million times. That's how an optimizer can take a printout, it gets a picture of what it would look like. Yeah, not quite. Let's move a little bit closer to the goal. And that is essentially the core of our software. We can do these optimizations, which are really not what conventional 2D print software does. So we're really able to unlock the full potential of color 3D print with this approach that is unique to us.
Now it's coming to my mind. You mentioned movies and the companies that are dealing with the movie. Who are potentially your clients? Because I suppose that it could be even from different technologies. It could be maybe car companies. It could be maybe a movie company. Who are potentially your clients?
Well, it's a bit of a chicken and egg problem, which is fortunately now moving to the stage where there's chickens in the yard. The thing is, the technology to do full color 3D printing has existed for the better part of 10, 15 years now, the PolyJet technology, developed by Stratasys and others. But the materials so far were quite brittle. So you could print something, but the objects would not be very durable and they would be very expensive to print as well, because the materials are expensive. So this was more for niche applications like doing prototyping. You have an idea for a consumer product and you want to show it to the board. You do this very expensive printout as a last stage to get approval for the appearance of your product. But for end user uses, no. But this is now changing because a company we're collaborating with is finally making a printer that can print full color, durable materials.
All right.
And this might change, for some applications, some medical, some just for bespoke manufacturing. This is going to make a difference. You can finally make durable objects in full color, plastic objects, of course, but still. One application, for instance, is teeth. Dentures, because these are a cosmetic thing as well as a functional one. Okay. Now that they can be printed from hard plastic that is hard enough to actually use the dentures, you can directly print teeth that match the appearance of the remaining teeth of that person. So it's cosmetic, it matches the appearance, and it's usable.
And you're playing with the colors and all the structures.
With the color, and all we need is a photograph or a color measurement of the existing teeth, and we can match that. Printing little globes is one thing, that's a cute example, but there are actual cosmetic examples of medical things, but also you have a range of objects and one of them is missing and you want to replace the missing object, you need to match the appearance, be it for a museum or elsewhere. There are some applications for this, and so far nobody's really using this sort of technology because the capability isn't there. But now we're providing the capability, and we do foresee that this is a niche, but a sizable niche, where our software is going to be quite important.
So maybe it's a potential even for the museums?
Museums, bespoke manufacturing, somebody wants whatever, their car dashboard personalized, or a piece of furniture with certain ornaments in them, you can very quickly make that with that sort of printing technology. And also in the future, because our approach is not just limited to color, like 2D print technology for technical reasons mostly is, if the machines gain the ability to print, for instance, metallic, so you can combine metallic, appearance. We can already deal with translucency to print translucent and transparent parts in a controlled fashion, that you can make fairly complex objects on demand with comparatively low price and comparatively quickly. So there's going to be a niche, and we're going to be the ones doing the software for that niche.
Okay, nice one. To go back where you started, you all come from the Faculty of Mathematics and Physics from the Charles University. Is it where your team was built?
Yes, the company is founded by 3 of the founders are my former PhD students, and there's myself, and our specialty so far, as I've said before, was highly realistic computer graphics. Getting appearance of virtual things right. And now we're simply taking that to the real world because we're taking that capability. The research that they did was already partially on these technologies, but they also partially did research on generic graphics topics as well. So it's not like they only did appearance printing. For their research.
Okay. I think that we really have to mention, and it's correct to mention, that the work of Additive Appearance is based on the research of Jaroslav Krivanek's works.
Yes.
And I would like to, emphasize his role and to talk a little bit more about where it began with his research.
Yes, it used to. We used to be 2 docent for computer graphics at Charles University. So I joined MatPhys in 2009, if I recall correctly, and he came in 2011. And we've always had complementary specialties. My specialty is more physics and color, and his specialty was light transport. And he really was a pioneer there. He built another very successful startup company based on his research. So he was one of the leading researchers who made Monte Carlo image synthesis practical. Monte Carlo image synthesis is basically the capability of doing a virtual object in the memory of the computer and then getting a virtual photograph of it that really matches what you would see in reality. We were able to do that before, but not efficiently. He made it efficient. Okay. And usable by end users. So the startup he built, which is now called owned by Chaos Group, they, for instance, do software that's used for architectural visualization. You take the plans for a building, and even before Jaroslav did his work, you could get a picture from the plans that looked like a photograph, but it was tedious. You needed a specialist, and he made it usable and fast and convenient, and that's what he built there. And unfortunately, he passed away in 2019 before we could start Additive Appearance. But he was involved also in this research because one side is color and the physics and, and the material properties, but the light transport computations are at the very core of this. And he was the one who provided this.
And that's what you've mentioned when we were talking before the podcast in a very nice example. It was with the juice, that it's quite easy to print an orange juice, but it's quite difficult to print a kind of an apple juice with the light coming through.
Yes, volumetric objects are hard to do, and he actually pioneered ways to efficiently compute the appearance of volumetric objects. What's a volumetric object? This thing basically has a surface and you don't see beneath the surface, and everybody can imagine a glass of orange juice or apple juice. They're translucent. And for reasons, this is harder to compute than an object that just has a hard surface. And of course, these things are just with the surface, but we at Additive Appearance can also predict the appearance of objects that have translucent parts, in no small part due to the research that Jaroslav did on how to efficiently compute that.
back to your team. You're quite a small team, but you have your own roles in your team. Can you maybe introduce in a little bit more detail what all the guys do in your team properly, who does the numbers, who does the surface and physics, but on the language, so it could be crystal clear to us what you do and what's your responsibility.
Well, the team consists of, the core team consists of 4 people. We also have hired a developer now, but the core team is Thomas Nindl, who's the CEO, and he's a little bit older than the other 2 PhD students because he was working for a couple of years in Germany before he met Jardak Šivanek and started a PhD with him. And all 3 of them started their PhD with Jaroslav, although Tomáš Iza was only Jaroslav's students, I think, for 2 weeks before he left us. But Thomas Nindl, who's now the CEO, had a sizable part of his PhD tenure with Jaroslav, and has leadership and commercial experience. Plus, he was actually the one who made this run really fast, so he is a very capable researcher. But so he contributed a core technology component to this, but he's now the lead of the company. Tomáš Iza is the one who does the material measurements, because in order to compute what something would look like, you need the shape of the object, but you also need to know how light is going to interact with it. And of course, like every printer, the printer has some base colors, and you need to measure what this does when light hits it. And this is Tomáš's speciality. He's also partially staying at Charles University in a teaching position. And Tobias Rittig is the technology person, the head of development and technology at the company. He basically severed his, same as Thomas Nindl, he left the university and is now working full-time here, and he's focusing on developing the actual software, so he's the chief technology officer. I myself, unfortunately, have to basically full-time stay at the university because we are still 1 docent short. So there is a huge workload at the university. But I'm, of course, contributing in that I'm doing software development too and doing some research work and generally providing my input on tech matters. But the main workload is with the 3 people who transitioned here to CUIP, currently upstairs, the office. Okay,
we'll get to this because, of course, the additive appearance work, it's been for many years. It takes some time, sometimes years, to come up with the idea and to come up to the stage that you decide to do the spin-off. When is the time during the process when you really decide that now is the time to share and to share the knowledge, to share the idea, and maybe to share your ideas about making a company or license, or when is the time? When is the right time to be protective, but also to know that now it's time to come and talk about your technology?
Well, we are matfiz people, meaning we're hopefully at least pretty good with numbers. And we've been thinking about commercializing or doing something with it for a long time, obviously, because it started in 2015. We had the first quite important publication in 2017. That was for the 2D case, 2019, the 3D case. And in 2021, we finally brought it with another 2 key publications to the level where it's actually usably fast. At that was the latest point where we thought, okay, but this really should be commercialized. But then you need to be realistic. You need to look at the numbers. How much does it cost to finance ourselves? And then you look at the market, which was still far more in that chicken and egg stage. You know, color printing is fantastic, and there are use cases, but too few people are using it, or are they? It's really hard to gauge a market that's still emerging. But we did a lot of research there. We've been going to the key industry fairs for 3D printing, for instance, Formnext in Frankfurt. We've been talking to people in industry. Suppose we gave you a much better software to control the printer with, what would you do with it? So it took years of talking to people, to potential customers. So we actually had people who are using 3D printers, a movie studio, for instance. We told them, we met them at SIGGRAPH, and they talked to us, and they've been telling us, could you do something for us? Do test prints. So for years we've already been talking to potential customers, and only once all this condensed, maybe we're a bit conservative in that, but only once a market opportunity wasn't just theoretical in the sense, okay, we've got this fantastic technology, we're the only ones capable of doing it, but only after the numbers started to basically check out in that, okay, this could actually work, then we really started to talk to CUIP in earnest, and CUIP has been immensely helpful in getting this off the ground, because they provided all the logistics and help with starting a company. But it really, so far at least in our experience, it really pays to be conservative, because you can be too early with a good idea.
That's right. But we face it very often, that it's really hard to say, now it's a time, it's not perfectly ready, but it's time to talk, to start to talk to people around, and to potential customers, and to companies. And how do you maybe decide in yourself to overcome the obstacles, or later obstacles, to stop you to saying, no, it's still not a time, it's still not ready? How do you overcome this? Or maybe break the barrier, saying, no, even if it's not ready, it's still time to start talking about the technology?
I don't think you can generalize that. You need to have, you also need to be lucky in the sense that there need to be launch customers for what you're doing. And that launch customer of ours appeared, and everything was delayed by more than a year, because they wanted our technology, but it wasn't so easy to actually get the arrangement with them sorted, put it that way. And we played it conservative, and only once that was certain, we started moving. So it's probably a bit like meeting somebody you later marry, because those people who are married tell you, you'll know once you meet that person, it's going to be obvious. Once you have the technology, and you're in that position where you've been talking to customers, you've been surveying the marketplace, you're coming from the academic sphere, so that takes a lot of learning to realize the market is probably a lot less advanced than you thought it would be, which is fair enough, because these people are adults, they have to earn money, they have to keep it conservative, because they have customers waiting, and they don't want experimental stuff so much. They want experimental stuff if and when it's adult enough to be used in anger. So you have to spend potentially years getting to know the market, getting to know the whole domain outside the lab, and then you'll know when the time is.
Okay, good point. You've recently attended a very interesting fair in Frankfurt. What is a prevailing feeling? You come back home with the feeling, or regarding the additive appearance, and maybe where it stands in a technology and in a printing out words. How do you feel about it after attending the event in Frankfurt?
Positive. More positive than I thought we'd feel, because this wasn't me feeling negative about it beforehand, but I tried to go to things like that without too many expectations. The thing is, our technology is still unique.
Okay.
But if you go to Formnext, that's at Frankfurt Messe, it's 4 big halls full of 3D printing technology. 4/5 of that is printing metal, because that's how adults earn money, 3D printing, rocket parts, aerospace parts, things you couldn't make otherwise. Then there's a smaller part, monochrome plastic printing, and color printing is a very small niche. But it's visible, and it's going to happen, because now the technology to make durable color objects is emerging. And we spoke to end customers there. print studios, for instance. There's printing services, and they all said, if we could have your software, that would be really great, because one thing of our software is, you're going to show these pictures in close-up in the podcast video so people can better see it. But one of these things is blurry and the other one looks sharp, so we can optimize these prints. But the funny thing is, the main thing people are interested in is actually not so much the optimization. They say, okay, we'll gladly take that if we get it. But being able to see what the thing is going to look like once you print it, because that takes hours to print. It's not like a desktop printer for 2D. So you craft an object, it looks like so on the screen. You press print, you wait 8 hours, and then the colors are off. You have to print it again. That's a waste of time and energy and resources. And we can predict what it's going to look like. That's an intrinsic part of our pipeline.
All right.
So the main thing that people are waiting for, actually, we want your software, is give us the button where we can see what the printout is going to look like. If you optimize it, we're not going to sneeze at that, but, you can predict. Great.
Okay, good.
So that was the feedback from the show. They all are looking forward to the prediction feature.
So you feel positive?
Yes, positive, fortunately.
How many hours does it take to print this kind of a globe?
I would love to give you an accurate quote. My guess would be something probably 8 to 10 hours for this at least, because...
With this kind of a small object?
Well, the thing is, it's built layer by layer, and the dots, the little material droplets, are 1/10 of a human hair. Otherwise, because these globes are not actually the best example, because you can print fairly intricate features. We just don't have an object like that standing around here, unfortunately. We should get one just to show people. This can't just print spheres, it can print pretty intricate objects. And what it also takes is some post-processing, because when it comes out of the printer, it's not as nice and shiny and glossy as this, so you still have to manually post-process. This is also something we're going to work on, predict what the post-processing is going to make the object look like. So, because we're the prediction people, so give us the data. This is going to be Thomas Iser's work. Measure, predict, optimize. We can do the whole pipeline. We don't do the printer, that's other people's job, but we do the whole software stack.
So this is the vision probably for the future, where the additive appearance goes.
Yes, we actually have a very clear roadmap of what we're going to add in terms of features, because our software is capable of adding additional appearance attributes fairly easily. We don't bat an eyelid if we've got another material that has strange, non-conventional appearance attributes like metallic or fluorescent. We can deal with that. And the main reason printers don't have these materials now is because the printer drivers, the normal ones, can't deal with them, but we can. So we have a fairly clear vision of extending all the appearance attributes you can have in a printer.
Perfect. So fingers crossed for you, and I hope that you do well, and you're still so happy about what you do. And thank you very much for visiting our podcast and talking, sharing about your software and technologies.
It was a pleasure. Thank you for the invitation.
And I thank you very much, and I hope to see you for next CUIP On Air podcast.